Algebra 1, Part 2, Graphing Quadratic Equations, Properties of a Parabola and Quadratic Equations. This is all information that is absolute must know. So we're going to get right into it. We're going to be factoring and graphing this particular function. Once again, I'm reminding you, f of x and y, same thing, and I'm going to use them interchangeably here. So we're going to go right into our factored form of our function. Our function x squared minus 2x minus 3, easily factored. We've got a 1 as our leading coefficient. So factors of negative 3 that add up to 2, x minus 3, x plus 1, which will help us to very easily fill out an xy chart. Because if we let f of x or y be equal to 0, we can solve for the x-intercepts of this particular function. So x minus 3 equals 0, x equals 3. X plus 1 equals 0, x equals negative 1. So we have x-intercepts at 3, 0, and negative 1, 0. This was the whole reason that we've spent a week learning how to solve by setting equal to 0. It tells us where we can start our graph with our x-intercepts. Now, let's also find our y-intercept because that's a very easy point to find. Remember, to get to the y-intercept, we let x be 0. So f of 0 will be 0 squared minus 2 times 0 minus 3. When we plug in that 0, it's going to cancel out any term that has an x from the original given function. And all that's going to be left is our constant, negative 3. So let's take a moment. Let's plot those points. So over 3 up 0, there's our first point. Back 1 up 0. And then our y-intercept is at 0, negative 3. Now, our y-intercept is not in the middle. In the middle, in between our two intercepts, is going to be our axis of symmetry. Our axis of symmetry is a vertical line, and since it is a vertical line, it has an equation. Our axis of symmetry, which normally I'll just refer to by AOS, is simply x equals 1. X equals 1 is our axis of symmetry. So if our AOS is at x equals 1, we need to plug in 1 into the function, f of 1. You can plug it into the given function or the factored function. Either one, it doesn't make a difference. I'll plug it into the factored. 1 minus 3 times 1 plus 1. 1 minus 3 is negative 2. Negative 2 times 2 is negative 4. This is the location of our vertex. Our vertex lives on the axis of symmetry. And in this case, since our leading coefficient was positive 1, this parabola is going to be opening up. The leading coefficient gives us all the information we need as far as up or down. This one will open up. Therefore, our vertex will be a minimum value. A minimum value because it's the very bottom of the parabola. Now, we're going to use the whole idea that parabolas are symmetrical to extrapolate another point. So if we have a point that's 1 unit to the left of the axis of symmetry, we'll have one that is 1 unit to the right. 1, 2, 3, 4, 5. 5 points is all we need in order to graph our smooth curve that is a parabola. So lastly, let's fill in the blanks on this page. Parabolas are symmetrical. Parabolas are symmetrical. If I were to fold the piece of paper on this yellow line, the points on the left side would mirror the points on the right side. Parabolas are symmetrical. Second, to find the y-intercept, there's only one. Just look at the constant. Just look at the constant in the given function. That's how we can easily find the y-intercept. Next, let's graph y equals negative 2x squared plus 2. Same strategy again. Start by taking the function and factoring it. So we have a negative leading coefficient. So if we have a negative leading coefficient, I am going to anticipate that this parabola is going to open down. That's what that negative 2 is going to do. Now, I am going to factor out that negative 2 because it is a common factor of both terms. So when negative 2 comes out, I'll be left with x squared minus 1. X squared minus 1 is the DOTS, the difference of two squares. So we can factor again. Y equals negative 2 times x minus 1 times x plus 1. If you need to review how to factor the difference of two squares, back it up and look in the Chapter 7 Google site and you can watch that video. So now that it is completely factored, we can set it equal to 0 and we can find the x-intercepts. Now, in the previous video, I told you that if we take out an integral greatest common factor, we do not need to set it equal to 0. Just the binomial factors. So x minus 1, x plus 1 equals 0. X equals 1, x equals negative 1. Those two values give us our first 2 points. When x equals 1, y equals 0. When x equals negative 1, y equals 0. Let's plot those points. There they are. And directly in the middle, in between those 2 points, is the axis of symmetry. And in this particular graph, our axis of symmetry is on the y-axis. So our axis of symmetry, our AOS, is x equals 0. Our axis of symmetry is x equals 0, which also means that our vertex will be on our y-axis. So plug in the 0, look at the constant. The constant in the given function is 2. So 0, 2. We're anticipating that this parabola will open down, so that vertex, our y-intercept, one and the same in this situation, I'll label that vertex and y-intercept, same point here. This is not a minimum value, it is a maximum value in this case, because the parabola is going to open down. Now, we've only got 3 points. That's not enough. We need to go one more value for x in the domain in order to find a 5th point. Now, it would not make sense to plug in 5 or 7 or 9 or negative 6. We want to plug in something close to negative 1 or positive 1. I'm going to go with 2. Plug in 2. And you can plug it into the given function or the factored function. It doesn't matter. I'll go with the given function. So f of 2, evaluate the f function when x equals 2. So that will be negative 2 times 2 squared, because I'm plugging it in right there, plus 2. Follow order of operations, square first. So 2 squared is 4. And then negative 2 times 4 is negative 8, plus 2. That is negative 6. 2, negative 6. Plot that point. Over 2 and down 6. So once again, because parabolas are symmetrical, if there's a point 2 units to the right, there's one 2 units to the left. Because our leading coefficient is negative, it goes down. But because our leading coefficient is negative 2, this parabola is much taller and skinnier than our previous parabolas. The farther the leading coefficient gets away from 1, the taller and skinnier the parabola becomes. So, axis of symmetry, x equals 0. Vertex at 0, 2. X-intercepts, 1, 0, negative 1, 0. Those are all the critical points that we're looking for when we graph a parabola. Okay, let's wrap it up here with our steps to graphing. So here they all are. Steps to graphing. First thing, factor the polynomial. When you factor the polynomial, this allows you to easily find the zeros. Remember, zeros are the same thing as x-intercepts. Next, plot the zeros on the x-axis. After you plot the zeros on the x-axis, you can easily find the axis of symmetry. Plot the axis of symmetry as a dashed line. It's a dashed line because it is not technically part of the graph. Next, plot the vertex on the axis of symmetry. And next, plot the y-intercept. Remember, the easiest way to plot the y-intercept is to simply look at the constant value that's in the given function. And then finally, your graph, to be complete, should have 5 plotted points and then a nice smooth curve drawn through those 5 points. Thank you for listening.